Okay, so today we're going to deal with general rules of exponents. There are 5 such rules of exponents. So we'll start with number 1. A to the power m and multiplied by a to the power n. So we have here a situation where the base is the same, and it's going to be, once the base is the same and it's multiplied, then the powers or exponents can be added, right? As an example, then if we give this example, 2 cubed times 2 squared, it's going to be 2, 3 plus 2, which equals 2 to the 5th power. Of course, we can test this, right? We can do 2 times 2 times 2 and multiply again times 2 times 2, right? Of course, because we have parentheses, the parentheses can go away, so it just becomes 2 times 2 times 2 times 2 times 2. We can see that it's 1, 2, 3, 4, 5 times. So it is indeed equal to 2 to the 5th power. So this can be tested in that way, at the very least. The second rule is that if we have a to some power n, then a multiply again to raised again to a power n, then those powers can multiply. So it's going to be a to the power m times n, and we can have an example. Let's say we have 2 to the 3rd power raised again to the 2nd power. So it's going to be 2, 3 times 2, which is 2 to the 6th power. Once again, we can test this. So if we take everything in the parentheses, we do 2 times 2 times 2. We square it, and we square it, so it's going to be 2 times 2 times 2, 2 times 2 times 2. Of course, with the parentheses we can get rid of them, so we just know that it's 1, 2, 3, 4, 5, 6. So it indeed equal to 2 to the 6th power in that vein. Now, the third rule, general rule, you see here. So we have, if we have a to some m power and a to some n power, the caveat or the limitation being that a must be different from 0, because we don't divide by 0, then this is going to be equal to a to the power m minus n. So it's a way of rearranging that rational expression to something that may be easier to deal with. As an example, we can take two cubed over 2 squared for an example. So if we do that, it's going to be 2 to the power 3 minus 2, which equals 2 to the power 1, which in fact equals 2 itself. Now we can once again test it. 2 times 2 times 2, 2 times 2. So this cancels, this cancel, we're left with 2 only. Okay. The fourth rule is if we have 2 different bases, same power, ab to the power m then the power will distribute. So it's going to be a to the power m times b to the power m. As an example, we can have maybe 2 times 3 squared, right? So we're saying that it's going to be 2 squared times 3 squared, which is 4 times 9, which is 36. Okay, now we can test again. So 2 times 3, 2 times 3. We can get rid of the parenthesis, so it's just going to be 2 times 2 times 3 times 3, which is 2 squared times 3 squared. So that works. Okay, I'm going to have to erase this side here so I can have room for the fifth rule. So the fifth rule, number 5, it's when you have two different bases divided by each other and raised to some same power, the power distributes once more. So it's going to be a to the power m, b to the power m. Now an example of this, we can have, for instance, 6 divided by 2, that's squared. Of course, the caveat here is that b must not be 0, right? And we're saying that this is going to be 6 squared divided by 2 squared, which is 36 over 4, which is 9. We test it, so it's going to be, if we just take what's in the parenthesis here, 6 divided by 2, that's 3. 3 squared equals indeed 9. So the two expressions on either side of the equality are indeed the same. Now we can make, therefore, our summary, and this is a little bit messy here, sorry about that. I'm going to try to clean it up a bit and then give the final rules. So in summary, we have rule number 1, a m times a to the m, that's going to be am plus n. Second rule, if we have am to the power n, it's going to be am times n, right? Third rule, a to some power m divided by a to some power n, we have am minus n. Fourth, ab power m is going to be equal to a to the power m, b to the power m. And then fifthly, that is fifth rule, a over b power m, that's going to be am bm. Let's not forget the caveats. So b must not be equal to 0. It can be any real number not equal to 0. And here there's a caveat here as well, that a cannot be equal to 0, and once again that's because we don't divide by 0. Now this concludes our discussion of the 5 rules, general rules of exponents. Don't forget to like the video and to subscribe the video. It will help me to grow my channel. I hope this helps you. Have a good day.